Hello, and welcome to the worst timeline. I'm here today to talk about why omniscience is impossible. We'll start with the part that simply talks about an abstract computer program called a Turing machine, which some of you have heard before. Then we'll get to the part that applies more generally. So, the only fact you really need to know about a Turing machine here is that it can be defined in arithmetical terms, which should make sense to those of you who've heard about computers at some point, because you know that computer program is basically just a pattern of ones and zeros. If we don't care about whether the computer itself will catch fire before the program finishes running, then it's basically just a property of arithmetic. For example, whether or not the program will stop at some point for a particular input, something that we feed into the program, or whether or not it will run forever as in a loop without actually doing anything in terms of answers or other outputs from the program. This seems to be a well-defined mathematical question for a given Turing machine or abstract program and a given input. But we can prove pretty easily that there's no computable way to look at any given Turing machine and to tell in full generality whether if any possible Turing machine will halt for a given input. Because if we did have a computable way of doing that, we could modify that abstract program with the following instructions: feeds the program you're looking at its own source code as input, and if the result is that the program halts, then go into an infinite loop, and if it does not halt, then halt. And then we feed the program its own source code and watch it vanish in a puff of logic. So that's why the full halting problem is uncomputable. There's no fully general algorithm that can solve it for all programs and inputs. And this is sometimes used as a reason to believe that there must be some special property of human consciousness that allows us to get around this problem. Although I'm not sure why anyone would believe that humans have a special ability to tell when a computer program will halt. You may have noticed that every piece of software you ever used has had bugs. That's not very encouraging for our magical program predicting abilities. But anyway, now we introduce the idea of an oracle, which is uncomputable magic, or a black box that we might choose to assume can tell when any given Turing machine will halt for a given input, or in general can spit out an answer to some problem. We don't need to assume anything at all about the oracle itself, just that it could give such answers if it wanted to. We could assume that the oracle is the Fae, and that it would never in practice give honest answers, and it still seems like it should be a meaningful question to ask what would happen if it did. So now, as soon as we just define what it means to get an answer from an oracle and feed it to a Turing machine, which is the sort of thing you'll find if you look up this question of oracles, we immediately have the concept of an oracle machine, which is just a Turing machine that can get answers from an oracle. And now the exact same proof as before goes through. The Turing machine is just acting here as an abstract aid to get us a cleanly provable theorem. It's, as we saw, just a hypothetical. Now, you may think that this is extremely abstract and not very interesting, and I would be happy to just get agreement that the same applies to the halting problem for Turing machines, and that it doesn't prove that humans have some special magical property of consciousness or that consciousness, I should say, has some special magical property that makes us uncomputable. I'm happy to grant that human beings generally have consciousness, but I think there's a serious issue with saying that the whole concept is meaningless. Because, for example, there's a close connection between the implied hierarchy of oracles that we just laid out, where each oracle and oracle machine has its own halting problem, which we could assume if we chose is solvable by a higher level oracle. There's a close connection between that rather odd concept and what's called the arithmetical hierarchy. Briefly, you can talk about what it means to define sets or properties of numbers, starting by noting that if we can check individual numbers to see if they have some property, say encoding a proof that 2 plus 2 equals 5 in a standard formalization of arithmetic for a given coding, uh, we can check individual numbers to see they don't have this property. And then such claims allow you to write a program which will always prove that the statement is true if it actually is true, because the program will just go through all the natural numbers. And if there is such a number with that property, it's guaranteed to stop eventually. And likewise, we can write a program to check if a statement about all numbers like this is true. It's not guaranteed to stop if the statement is true, but it's guaranteed to stop if the statement is false, and then it can find a counterexample at some point. And it may happen that such statements can be proven or disproven in a different way, but we can say without looking at the details that it's always going to be possible for the answer to be computable in one of those cases. And in similar ways, we can ask what happens if we have a magic oracle feeding answers to the Turing machine. And this gives us what's called the arithmetical hierarchy for defining sets of natural numbers or properties of natural numbers, which is, closely related to the formal language that we'd like to use for the theory of arithmetic. So I think this is too important of a mathematical concept if you think that statements about arithmetic are true or false to just claim that the whole idea is meaningless.